Hey guys, what's up? Welcome back to another episode of It's About Everything. So, in my previous episode, I told you that I'm going to build a PWM DC motor controller. So, this is the prototype on the breadboard. So, it's basically very simple. The main controller, the chip is a 555 chip, which is right over there on the breadboard, and everything is connected. You can see it's a huge mess here with all the jumper wires and everything. So the simplest uh, way you can understand is with this schematic right over here. Let me turn the camera. So here the circuit is working in a, a stable vibrator, multi vibrator, where the circuit oscillates continuously. So here the duty cycle is changed continuously through a 10k potentiometer, which actually varies the duty cycle and which in turn controls the DC motor. Now uh, here a diode is added on the motor side, so that when the motor is turned off, it has a reverse spike of current which will destroy the Mosfet. So to prevent it from destroying the Mosfet, you need to connect a diode in parallel with the DC motor. Okay, so I will explain the circuit later. Let me show you how it works. Okay, so this is the DC motor that I built not too long ago. So let me turn it on. Okay, so the motor is running at a lower RPM right now, and when I turn this potentiometer clockwise, it starts increasing the speed of the DC motor. I hope you can hear the sound of the motor on the microphone. So the brightness of the LED does not goes completely off. First of all, this LED can run at a very lower voltage, and that's why it keeps on glowing, and my camera is not properly showing it, but it's slowly dimming, and as I turn the potentiometer, its brightness increases. So the duty cycle is on the lower side. It's close to 10%, 8, 9 or 10% probably. I don't have a oscilloscope, so I don't know, but the motor is still turning even when I turn the potentiometer completely on the counterclockwise direction. So this means that the duty cycle is not 1 or 2% or 0%, which is probably because I have a 1k resistor connected. I will explain to you in a second. So but on the high side it goes to full speed, but on the lower side it keeps on turning. So why is that? So let me explain it to you. Okay, so why the motor was not completely turning off? That's because the duty cycle was not completely at the lower level, 1% or 2%. It was around 9 or 10% probably. I don't have an oscilloscope, so I don't know. So how this circuit works actually is, when the output is high, at that time uh, the current is actually flowing through this direction and it's charging up the capacitor, and the longer time it takes to charge up the capacitor, the longer the duty cycle is going to be. So the duty cycle is going to be around 99%. But when the output here it goes low, that time the capacitor discharges through this way, and it takes a shorter time. If the potentiometer is completely turned towards the right side, then it will take a short time to discharge and long time to charge, which will mean here that the duty cycle is close to 98-99%, or the motor is turning at high speed. But on the other way, if I want the duty cycle to be very low, which means I want the motor to completely turn off, at that time the capacitor needs to be charged super fast and discharged at a slower rate. So when the capacitor charges, it charges through here. Right now you can see the arrow is pointing towards the left, which is at the lower setting of the circuit when the duty cycle is going to be very low. So the capacitor charges through this way and through this 1K resistor, and when it is discharging, it is going through this way. So it's taking a longer time to discharge and a very short time to charge. But here, due to this 1K resistor, it's also taking a little bit of time to fully charge, and that's why it's giving a duty cycle, and that's why it was giving a duty cycle of about 8 or 10% probably. So the wave, so it was producing something like this, and when it is fully turned towards the right side, at that time it was charging, the capacitor was taking a longer time to charge but a shorter time to discharge. So at that time the duty cycle was close to like this. So here the duty cycle is close to about 98-99%, but on the other side it's about 7 or 8%. So in order to completely turn off the motor, what I need to do is I need to remove this 1K resistor, but I cannot do that because it's connected with the discharge pin. So I need to remove this 1K resistor, and I need to disconnect it from the 7th number pin, and I need to connect this section with the output, and this way it will take same time to discharge and same time to charge, and the duty cycle will be much lower over here. Let me show that to you when I reconnect everything on the breadboard. Okay guys, so before rewiring everything to this way, I want to show you that the transistor that I used over here, this Mosfet, is an IRF Z44N. It's not Z46N because I was unable to find Z46N, so I used Z44N, and I connected the diode that is connected in parallel with the motor. I connected the diode over here, right at the base of the battery, from where the connection goes to the motor. So that's why you are unable to see the diode in the breadboard. Okay guys, so let's begin rewiring the breadboard according to the new schematic. Anyway, so let's begin rewiring it. So first of all, I'm going to remove the 1K resistor. So this is the 1K resistor right over here. and I'm going to open the discharge pin. So this is the discharge pin, so it's not connected anymore, and I'm going to connect the diodes, which is right over here, to the output of the 555 IC. So this is the wire that is connected with the output, that is going to the resistance and then to the Mosfet. So I'm going to use a longer jumper wire to connect it. So right over there, and alright, so you can see this is the output, it's coming here, and this white wire actually is going back to the section where the diode is connected, which is right over here. Okay, so let me check the connections again. So pin 7 is disconnected and it's connected with the output right over here, and the 1K resistance is open. Okay, so let's give it a test. I hope I wired everything correctly and it will not burn. Okay, so let's see. Okay, it didn't turn on, the motor is still off. Now let me crank it. So now you can see that the LED is also dimming, so this means that the duty cycle now is close to or less than 1%, close to 0% probably, because I can still see a little bit of glow on the LED, and on the higher side I think it's close to 100%. And if I reduce it, you can see the speed also reduces. And it's turned off. Okay guys, so this is the schematic that I got from the internet, and according to the schematic, the oscillation frequency is about 20 kilohertz to 30 kilohertz, and the frequency goes up and down as I adjust the duty cycle. And this type of circuits, in this type of circuits, this change in frequency is pretty common. It does not affect the operation of the motor or light or anything that you are controlling. So I found that this design where you bypass the discharge pin and you connect it with the output is much more efficient, as the duty cycle is more controllable. But where if you are using that, if you are using in a circuit where the duty cycle to 0%, close to 0% or close to 100% is not necessary. All you need is just to change the speed of a motor or the brightness of a bulb, to a certain extent, then this design also works best. And actually there are lot of combinations of using a 555 timer IC to produce a PWM, such as I have shown you here two ways, but there are other ways as well. For example, the pin 3 is the output, but you can use pin 7 probably for output as well, where you need to use a PNP transistor to use your output, or a P channel Mosfet. So there are various combinations. I will talk about it later in some other video. So right now the motor works perfectly with the proper duty cycle. Okay, so one more thing I forgot to mention is that the resistance that is connected with the MOSFET is a 200 ohm resistor, which is shown on the schematic, but I'm using a 330 ohm resistor. And in MOSFET it actually doesn't matter, because the MOSFET does not need current to operate, it needs voltage. That's why MOSFET are much more effective. So you can use 300 ohm, 400 ohm, it doesn't matter, it will work. And the MOSFET doesn't even gets warm while operating the DC motor. And if I touch the 555 IC, it's also not getting warm at all. It's not supposed to get warm actually, but still I'm checking, because if you give too much load on the output pin 3 to discharge and charge, then the IC might got damaged. So that is why I also checked that if the 555 IC is getting hot or not. But actually it's dead cold, and the MOSFET is also super cold. It's not even warm. So this is how a PWM circuit works. I'm not going to make a prototype PCB in this type of Vero boards. Instead I'm going to use this breadboard as the main circuit board, and I'm going to use it on this breadboard. So you can see here a lot of wire, huge mess of wire. So I'm going to sort all these wires, and I'm going to keep all the components. I'm going to arrange all the components properly, and I'm going to sort out all the wires so that it looks good, because right now it looks like a mess. So I'm going to make another video how I sort out all the wires. Okay, for now I'm going to connect it with this 12 volt LED bulb, and I'm going to show you how it works. Okay, so here you can see I've connected a 12 volt LED bulb, and I've also kept the DC motor connected, and let's see how it works. And it works like a charm. So this was it guys, I hope you enjoyed this video. If so, then hit the like button and share it with your friends, and if you are new, then subscribe to my channel. So in my next video I'm going to arrange all these wires and remove this wire mess, and I'm going to arrange the parts as well, and I'm going to use this breadboard as the main circuit board, and I'm going to update this circuit as well with some other components for some other purposes as well. So you will see. So thanks a lot for watching. I'll see you soon. Have a nice day. Bye bye and take care.